Alright, so today is a bigger lesson. We're gonna go actually into the Lana account, and we're gonna go ahead and see what is inside the Hans home. So the password is capstones 2018, and it's in the documentation as well. So let's check inside, see what is going on in here. The launchpad I'm currently using is from room 1, so we're going to be looking at room 2 today. And I went ahead and opened the code for us today already. So here is are all the different control widgets, the sliders, the digital input output indicators. Check it out, motion just went on inside the room. Here is showing the status of the air vent, so the air vent is open. So let's just show you, look, simple. As you can see, the lights are off inside the room, but I'm gonna go ahead and turn on these lights, and we just need a couple seconds for this. Couple seconds for this to update, but you already saw that the lux value increased. Let's see if it does it again. Okay, so 261 lux inside the room. But today we're gonna go over a good overview of the first tab, and this is the main tab that you need to learn, because all of these are just functions that run off of this main loop, and it'll be important to kind of show you how this operates. So first things first, this is defined in every new sketch that you add. Here are some defined global variables: debug motion, debug times, and moisture. If you activate these to a 1, simply you'll get new printouts. Say if you're debugging motion, you get the value of motion every time it runs through that motion test. Debug times is kind of useful. It'll show you the exact time in milliseconds of when you've entered into, say, a monitor function. So basically every time you enter one of these, so let's not have too many open. Okay, so here are all the header files you need if you want to use any of these functions. For the Hans room, you just need to know that these are the libraries we're accessing. Here is the same case, but just a different username, password, and client ID. Now we're initializing the PWM class so that we can use that to control the PCA96 servo driver. As you can see here, this is where you set the address. So 41. If you wanted to add a new PWM driver on the same Lana PCB, you would just change the name of the class. Of the variable. The class is the same, but you would add a PWM2 and change the address, and then you would simply come down to PWM.begin. So then you do PWM2.set .begin, and then PWM.set and actually you don't need and then PWM set .set PWM frequency. So you would do that. Say if you wanted to use a different frequency for that PWM, you would just kind of add in that new variable. So here, simple timer. Here is a timer class called simple timer. You're initializing the communications, initializing the I2C to talk with your sensor pack, and here is where you begin connecting to Wi-Fi. These are initializing your sensors if they're equal to 1. That is, if you allow them to be 1 here. Here we're initializing the PCA9685 on each launchpad to 60 Hz. Actually, we did change this to 120 because it makes our lights strobe less. Here we're setting some pin modes, and incidentally, if you wanted to understand these, you would go to Energia reference, and this is where you see the statements that control GPIOs on your launchpad. So the digital signals, digital read or digital write, it gives a great description, and this is pretty much where you would learn a lot about that. So let's go back into the room. Here we're setting a time for our simple timer. You just have to type in the minutes in this variable header. So if I go to minutes, see if I can find it. Okay, so minutes, so I have it at 28 minutes. Probably inconvenient to have to go over there, but it's just kind of a nice setup. So here this is in milliseconds. So 28, times 60 times 30 minutes. I feel like I might need to take that out, but I'll think about that again. I feel like I just did that too quickly. But here is Cayenne setup. So this is a function call to here, as you can see, Cayenne setup. So it'll go in here and initialize all the channels that we need to submit. So you can see here channel 1, channel 2, channel 3, channel 4. And that gets that set up. So this is if you wanted to add another timer, this statement right here. Because each timer that you use can have up to 8. So what I mean is, so you can have timer.set interval, 7 seconds, and you want to call it hey here, hey there. All you would do is you would go to see here's energy timer. Here's the one that I do have right now, the energy timer function. So this is its callback function that will go to this every 28 minutes. And that is if you're in energy mode, which we'll discuss later, and it's also in the documentation what that does specifically. So okay, so now we're going to get into the crux of our program, and it's a continuous loop. Let's just make sure we're still recording. Yeah, okay. Just had to check that because it's been messing up earlier. Okay, so here is the timer run and Cayenne loop. These have to be inside our main loop in order for them to operate. Here we have a serial print loop so that you can see every movement. Okay, so now we're just going to show you an example. This is 5,000 milliseconds, which is 5 seconds. So and our sensor check is our sensor check variable in milliseconds is 2,000. So if we go here to sensor check is equal to 0. So whenever so since this is 0, if this was 5,000 by the time it got to this if statement, so 5 seconds have passed, then we would obviously enter into this if statement because 5,000 is greater than 0. And so what we're doing is now we're getting this value of 5,000, which is still this, so milliseconds and milliseconds. It might be like 5,001, but it's very small. And then we add sensor check ms milliseconds, which we define here as 2 seconds. So what we've done is essentially added these two values to equal 7,000, which is now 7 seconds. So then this value has updated to 7,000. So you can see here sensor check, sensor check. It'll go through all these functions before it does that, but in the next round, if 6 seconds has passed, we won't enter into this statement. So that's kind of how it does it every other 2 seconds. It enters into this function. So finally, once it passes it, 7,001, then it'll enter into here, add 7. So this would now be 7, 1. You add 2 all the time. So now this is 9,001. And then this gets updated as well. So now this is 9,001. And I just put the 1 there just to show you that it's not as accurate as possible, but it does get within the 2 second range most of the time, or almost all the time actually. So here is another same expression, but now it's using 5 seconds. So every 5 seconds we'll go into this function. And that's how this works. This is our main code. These are the more important functions that we want to see closer every 2 seconds, and then we want to publish data every 5 seconds. So that way we're not overflowing the Cayenne web page. But that is how our program works. We'll go into the other tabs in the next video, so stay tuned.